All right. Hey, everyone. This is Taylor Laird and Delray Jordan's term project for CAP5415. As proposed in our original doc, we wanted to develop a system that could scan in essentially a whiteboard canvas or segmented off area, and then correct for the off axis, save that as a PDF so that essentially professors or TAs could do work in that and then save it and then easily scan that and to be able to use on something like web courses. These feeds we have here are, the top left is the unaltered original feed. It's a fairly harsh off-axis angle on a whiteboard. And then the top middle, this is our corner detection. As you can see, the red is where it thinks the corners are. And then finally, top right, this is our own thresholding on those kind of coordinate system. It's sort of like K-nearest neighbors, where anything up here should be clustered to the top left, top right, bottom left, bottom right. And it's all dynamic. As you see, we kind of move stuff, and as things move around, it adjusts where it thinks the center of this canvas should be. Bottom left is now we've found the true corners by taking the maximum Euclidean distance and then drawn our bounding box based on what we find the true corners are. And as you can see, as you kind of introduce things in and out of the frame, it'll kind of adjust to where the new corner values are and then try to kind of actively correct the bounding box. This bottom middle feed is not just a crop in, but an affine transformation of the bounding box to the left so that it will look like it's as if you're viewing the whiteboard from head on, and as Delray can show. We drew the word wow. As you can see in some of these images, it's off kilter a bit. This looks as if you're staring at it head on. Finally, this is canny edge detection on that feed, on that affine transformation feed. We were going to use this kind of for a stretch goal and a kind of game component, which we'll demo in a moment. A couple of other things that are neat to show about this system is it can adapt to different sized canvases. So you want to make something a little bit longer, maybe, that you're doing some sort of math homework or derivatives or something. So again, correct for that. Correct all the off axis. You can see this kind of moves around. The other thing too is the way we handle false negatives and true positives. You can see Delray is going to add a couple more shapes and things to the whiteboard that we can see up here are starting to trigger these the corner detection. But as you can notice, it may be moved around these thresholds a little bit, but as we're taking the maximum Euclidean distance from the center of this to the corner, we can still find easily the true corners. And then again here, the live feeds of both the affine transformation and the canny edge detection. Moving on to the next part. This is kind of the game component. We had a couple of little issues with getting the collision physics to work properly with the input from the canny edge detection, but this was kind of a stretch goal to just demo that we can, once we get this corrected, the off axis corrected, we can do whatever we want with it.
You did get the edge collision going, which was fine. It's just any object that showed up in the center or away from the edges wasn't quite acting correctly.
One of the kind of last things is the application of this project is that it spits out a PDF, which is the final view of that affine transformation matrix. It's a little bit low resolution. It's just because we zoom in the cam and it's coming from a webcam, so it is what it is.
And mostly the lines that appear to be missing from the scans is because of the lighting in the zoom off of the board. So it shows up brighter, it doesn't show up those dark lines.
All right, thank you.